All right, let's just make up an example. I've listed my h sub o is mu is less than or equal to 50. H sub 1 is greater than 50. And this particular problem, the sample mean is 52. All right, and we generate a p-value, and it's 0.0356. So remember, by definition, the p-value is the actual area under the curve, representing the probability of a particular sample statistic or more extreme statistic occurring if the null hypothesis is true. Okay? So if the p-value is 0.0356, the probability of getting a sample mean of 52, that's your sample statistic, or greater is 0.0356 by definition. That is, if the true population mean is 50. So let's look on the next page. And I've drawn a normal distribution, and the mean is 50, and the sample mean was 52. Remember, the p-value is the area or the probability under the curve. Okay, so this distance, from here on out, so I'm saying this area under here is 0.05. That's when I say alpha is 0.05. Okay? If I let alpha be 0.01, it's going to be this area here. Okay? And then the p-value is the probability under the curve. In this case, it's 0.30356. That's all of this. So, for p equal 0.0356, h sub o would be rejected at alpha equals 0.05 since the p-value is less than alpha. This p-value is less than that, all the 0.05 to the right. For a p-value of 0.0356, h sub o would not be rejected at alpha equal 0.01 because this green area, 0.356, is greater than the 0.01, this piece here. I hope that helps some.